Okay, let's go. Okay, so please be seated. So before we start, so Remy asked me to give you some precisions about publications of the presentations. So they will be online within a few days. So for those of you who made presentations, who gave presentations, please tell us or tell Remy or the intensys for you team if they can be published as is, or if you want to amend them before they can be uploaded online on the ETIP-SNET website. And regarding the minutes of the meeting, they will be also online, but I would say later on in 10 days from now. So it will be the conclusions of the meeting and the minutes regarding the Q&A from the presentations. Okay, so let's start this roundtable. So it is a very interesting topic. So flexible generation. So Jesus reminded us that flexible generation comes historically from thermal power generation, but it also comes from renewables. And then we had this very interesting presentation from Jan. So about the Irish system. So you curtail a lot right now. So your goal is to increase wind penetration and to curtail less. The first question I would like to ask you is about the way you do it. So you know certainly about the migrate projects and other research projects about how to operate a network when there is a lot of PE penetration. But when we look at your presentation, we get the impression that you will manage this PE penetration, so this wind power penetration, with rather at-hand solutions, classical solutions. Am I right or wrong?
You are, I'd say currently at the moment you are correct. So we have made some enhancements to our wind forecasting tool and things from a control center perspective. So the frequency that runs at, it used to be kind of 15 minutes, it's down to kind of 5 minutes. And there's other, I suppose, things within the control center that we have implemented to make us, I suppose, get to a place where the operators are comfortable to operate at those levels up to 60%. The big issue for us really from here on is it gets really difficult now. Up to this point, you can do it with some kind of tweaks to existing systems and things, but when you start getting above 60 and up to 75, that gap there, you have to have some very clear tools in place, voltage trajectory tools and things like that for the control center. So it's working well at the moment, but I think the next steps are particularly difficult, yeah.
Okay. When you were mentioning new technologies, because you said it would be a combination of several solutions and new technologies. So what are the new technologies? For example, the HVDC converters that would bring flexibility?
It's a possibility, yeah. So I think I said earlier on, we see ourselves as being kind of technology agnostic. So whatever is out there, we are willing, providing we can, like I said, providing we can measure it, and providing we can prove that it actually can do the services we're looking for, we are happy in that case then to potentially contract with it. So whether that turns out to be flywheels or we don't really mind, and we will accept proposals from anything, provided that typically we'll ask that they have evidence that it's worked in other places, or it's been installed, or they have evidence around that. And like I said, to date, we have asked that it would have a connection to our own grid, but I think we need to look at that.
Okay, but if I get it right, you have an approach which is fully in line with the recast of the directive that you just procure, and you look what's out there, and if there are market players that are able to provide the services that you specify.
Yeah, we specifically try not to pick winners as regards technologies, where that's not our business. Our business really is the goal is about getting high levels of renewables on, and whatever technologies are out there that can help to do that. Even if it's the case that existing thermal plant recommission themselves or decide to invest in their plant and do something different to be able to facilitate services we need at high levels of res, we are more than happy with that as well. So we're fairly open about it.
Okay. Susanna, do you think you can help Ian with your HVDC MMC technology? Is he going to help a country like Ireland? So I read that, I don't know if the project is really accepted now, that there will be an HVDC link possibly between the France, or Brittany, and the south of Ireland. Do you think this will help? Can you help Ian?
Yes, that way, of course.
Okay, good.
Yeah, well, I think the interconnector, the Celtic interconnector, if that was to come about, that obviously facilitates what I was talking about earlier on about exporting off renewables and having a chance to actually export when we have excess on the system and things. So interconnection is a big part of that. So it would be a full yes if it was to come about.
You want to complete, Susanna?
No, well, we have been working in these areas I have explained, but of course we never have reached high power, so we have knowledge about control, but real validation is quite far. But yeah, of course we can.
Absolutely. No. In fact, I think we are in face of a strong challenge, because we are now confronting with a situation in which the system design that we have in the power station, the system design that we have in the renewable need to be changed. Because now, at the beginning, what we did in the renewable was to produce as much as possible. This is how many hours of wind are? 30, okay, 30. 25. And then in thermal was the design just to produce as much as possible with an optimum situation of production. But now that we are confronted is, no. You need to follow what the renewable could be. Renewable need to follow one other kind of paradigms. And then this, to me, this opens a lot of opportunities for technologies, and is a strong challenge, yes, not only for the operator like us, also for the manufacturer and for the different actors that could appear in the market. Because, for example, the storage that could bring also flexibility will be able to, yesterday was a discussion here about, which is, will be everywhere. Where is the better storage? In which part? Close to the customer, close to the power station, in the middle, and then this is, in addition, open opportunities for bringing the market new, we can say, actors. Like aggregator, whichever like this. And then is an important and an interesting point in which we need to see the future so clear. And in fact, an important issue is you see the Commission is launching some kind of a strong challenge when in the winter package incorporate the balancing services. That is, not everybody now is able to do it. And then we need to do. And then, well, there is an interesting point, of a starting point now for this discussion.
And do you think, Jesus, that we have omitted something in the roadmap, in the arena activities which are specified in the roadmap or the implementation plan? After listening to Jan and Susanna?
I think we need to take a look at some issues, because we have concentrated a lot in the, we can say, in the classical vision, transmission, distribution, and production. And there are interfaces between these services and between, we can say, these three parts that are not specifically considered. You are able to see somewhere, but not clearly in some specific topic. And it is an issue that probably we need to rethink about.
Some questions from the audience, so following the remarks that were addressed now. Rainer. It's always the same guy.
Again, coming back to we are looking for topics which are we missing things here which we need to look at in the various work groups and in the research and so on. And I'm hearing three interesting words here, like provenability. Actually, I have very rarely heard that word. No, we need to have something which proves that it works. No, and you said measurability, and you, Susanna, you talked about scalability. Do we need research in these three things, or are these simply statements coming from projects and we just take them as given and they just happen as they evolve? Or do we need to do something there? Can I raise these questions to the three of you? What shall we do with these three words? Provenability, measurability, and scalability in terms of research.
So I think from the provenability and the measurability, because they're the ones I was probably taught about, we see those as critical components in order for us to procure services from technologies and things at scale. So as a TSO, we're a prudent operator. We do not want to let things onto the grid that could have a detrimental effect or could affect the performance of the grid. So unless, in conjunction with industry or whatever, unless it's the case that those things are proven and we can measure them, our sole goal with services is that how do we know you're doing what you're contracting for? And ultimately, if we're up at 75% and we have a contract for you for fast frequency response, regardless of the technology, and we need it, it has to be there. So we have to know it's there and we have to be able to be reliable on it. And ultimately, the performance monitoring we're putting in place, it works on the basis if you don't perform, you don't get paid. Which is a bit, I suppose, of a shift from typically traditional services where it was a case of an availability kind of payment as opposed to an actual kind of performance payment. So, but I think as an industry going forward, our high res, everyone needs that to work. It's not just an Ireland thing; it's a European thing. And some of the learnings we see in Ireland, we think are definitely applicable to the wider European grid as well.
Well, about the scalability, of course, it's a must to pass from the more theoretical or the little scale validation to do a step. It's necessary, of course, to see real problems. Yeah.
And additionally, confronting with the strong, I don't know what to say opposition, but heavy, we can say, requirement from the operator. Because I'm not able to test as you want in my system, in my wind farm. Go to your home and you do, but not with my farm. And then just to be able to test something, need to be really proven. And then it's not easy to say what is the really proven. If you pass from laboratory lab to real operation. Then sometimes this is an issue when you are passing from kilowatt to megawatt.
Yeah.
That is no evident, absolutely no evident. And then sometimes to have labs, maybe intermediate labs that are megawatt scale or something like this, or these capabilities are not easy to find.
It could help, but yeah.
Jan, you showed various timescales. You said that you would need approximately 14 system services to be procured so as to operate at a very high penetration of wind power. So there were a lot of different timescales.
Yes.
I was wondering, is it going to give birth to new markets, or do we stay on a classical balancing market for you guys, TSOs?
I think it has the potential, I think, to go to a new market. Like some of them are extremely fast services that traditional equipment and things, it just isn't available to handle. And from the measurement point of view, the likes of SCADA and things is no longer applicable for some of these services. On the market side, it's an interesting one because I think when we think about system, we think about system as a whole, kind of for the island and things. And ultimately, people's interaction with the market is a big factor in that, and whether they're available to provide services on top of their market position and whether they're selling energy into the market. And we have to make it more attractive for them to provide system services. In some cases, some of those technologies may not be in the market at all. They may be sitting there on 0 megawatts and actually aren't in the market. So traditional models of market participation with a small upside for auxiliary services or system services don't really apply in that. So your rates and tariffs then need to be set at a rate that also covers technologies that aren't necessarily within the actual market themselves. So yeah, it's
So that brings my next question to storage, because I was surprised that nobody asked the question. You never mentioned the word storage in your presentation, unless I'm mistaken. So you want to be technology agnostic,
yes.
I guess, which is good. What is your position regarding storage? Do you think it is needed, or could you operate your network without more storage than you have now?
I think we would. I think we can see a certain value in storage. Where I think our next set of trials, it'll probably be more focused towards storage and to get more kind of storage providers into that qualifying trial process to actually get them through into a procurement. So we are quite, I'd say, happy to kind of facilitate storage in trials and things as well. We have some storage connected. Some of it sits behind wind farms and things like that, so it's not direct connect. And we have had a good few, say, battery manufacturers and things come and talk to us, but ultimately it's about them justifying a business model for themselves to deploy those batteries or storage on the system based on our requirements around their fast response to events and to whether they think it's viable based on the tariff that is in place. But there's definitely a place for it. I think some of the things we're very conscious about is that we don't have too much over kind of capacity from a system services point of view, that we only need so much of things, and that we're not having procurement services that are so kind of open that we end up with too much capacity or on that, so we end up paying for stuff that we don't actually need at particular times.
Yes.
So when we talk about kind of having scalers at high SNSP and value of that, that's where we see the value of things like that. Storage for sure has a role in those places, but they have to prove that role. They have to prove that they're measurable, that they can be there, and things.
So I find this approach interesting. I don't know if somebody wants to react in the room. Yesterday we heard about other colleague transmission system operators that told us that they still have to experiment. They have to learn more about storage devices to understand what they can do with it. You seem to have a very different philosophy. I mean, you say, I will manage my network with or without storage. I will ask the market. I will see what's out there and what can be provided at reasonable prices. I will just do, as you said, transparent procurement.
Yes.
Once they can prove it, yeah.
Yes. So no, it's a question related to that is, storage is not new for us, for the companies. We know storage 100 years. So I remember my old company, this is 102 years. The first thing that they have a hydro station that now has been converted in a pump station. Meaning that, but the question is that the new opportunity that the storage is appearing now because the prices, and this is the opportunity, and also because this price go also to another opportunity to be distributed, to be able to customer to use, and then open new ways to use storage, but not because storage is not existing already. And this is because sometimes when you are in the company, you balance the capabilities that the storage give in confrontation with other solutions that you could find it.
Yeah. When I said storage, of course, I meant DB, SS.
No, I understand, but this is to mention, because sometimes we talk storage right now, and the Commission and other people, like we have discovered storage. Be careful, storage existing years ago, and then we use in many places already, and this is the issue. But the question is, we are confronted with new opportunities today.
Yes, thanks. Rainer, before I give you the word, maybe somebody else. Okay, so let's take Rainer once again.
Sorry. No, I totally agree with the word storage. I mean, storage is, of course, there are new technologies around, but I think many insiders even don't fully understand yet that we needed storage to have a so well working system in the past already, Of course, there's more volatility in there and so on. But my question is related to that. Inertia, you talked about this lower floor. I thought that was very interesting. This has to do with storage, actually, making it ready in very short time, you know. So what did you do there? Because this is a thing which we are all interested in, you know, finding out about the lower floor for inertia. Now,
so we know.
So what's the trick of Jan?
Well, it's more, we're not there yet as regards changing our values on our inertia flow and our minimum inertia. But so we know if we were to reduce existing sets and were to reduce existing conventional generation, that it has effects on the system inertia. But we think we can operate based on studies at a lower setting for inertia. But it also means then that we are looking at service to provide that if and when it was needed. And that's where the likes of storage and others potentially can do that. Wind farms and things have some of those capabilities. And that's I suppose, where the trials come into their own then to see can they actually do those things. But it is a critical part to getting to the 75%, yeah.
Thanks. Still no question. I have one question for you, Susanna. So you were mentioning in your research work on HVDC, on VSC HVDC, that probably some manufacturers are ahead of you and that it is very difficult to work together.
Mm-hmm.
So how do you see the future? I mean, some 2 or 3 major companies that are going to keep their secrets to keep a competitive advantage, and it will be difficult for the research world to contribute?
Well, yeah, well, sometimes is what I say, you need to scale up, and if you don't work directly with the manufacturer, it's not possible. So working in specific areas that you have work in, that's the step. So if there's no way to do it, you stop and think of any other things. But the idea of our research, yeah, if we can work with these manufacturers, perfect. But we believe that this market is going to change in the way that the projects, perhaps in a near future, are not going to be turnkey. I mean, the whole solution from the main manufacturer and perhaps different solutions could be done by a smaller manufacturer, as for example, some companies in the Basque Country. So in this way, we have something to do. Perhaps not aiming to work for the main manufacturer for the whole solution.
Thank you, Susanna. Questions? So if there are no questions, maybe I would propose to thank you for your valuable contribution. We are a little bit behind schedule, so that we move to session 4, and I leave the floor to Heiner.
So, next round number 4. That's the last of our 4 rounds. Smart networks, flexible networks was 1, flexible storage was 2, flexible generation was 3, and now we come to the digitization of this whole system. Some call it digital energy. And let's get the introduction by a representative of work group 4, which is Bruno Suarez, and from the R&D Nestor, and he will give a few introductory points about work group 4, and then we will have 1, 2, 3, 4 presentations of projects.
Yeah. I don't know if it's working now. So very good morning to all of you. So I'm Bruno, I work for R&D Nestor, and today I'm here representing the working group 4, which name is Digitalisation of Energy System and Customer Participation. We have a short name, Digital Energy. Basically, our chairman is the Mr. Maher Shebu. He's president of ESMI, and he works on GE Power. He was also chairman of ETP-SNET the demand and energy group. We have as vice chairmen Mrs. Esther Ardi from Aliander and also Miguel Sanchez from Iberdrola. We had more than 100 applications for our working group and around 70 were selected to be active members. The selection criteria was based, first of all, on the expertise of the members. So we have taken into account the need of a wide range of expertise on the energy sector. Then the stakeholders, then European coverage. We tried to coverage the 28 European Union countries still. Then the gender and motivation and time allocated to the working group. The remaining people are informed quarterly and invited sometimes as guest speakers in our meetings. So basically, we try to cover regarding the stakeholders, as much stakeholders related to energy as possible. So in our members, we have consumers, DSOs, TSOs, equipment suppliers, ICT technology providers, telecom operators, renewable energy sources providers, research and academia, and other minor stakeholders, but also important. Basically, we want to go towards digitalization, the digitization of the energy sector. And for that, having that in mind, we have a big transformation to do in the energy sector. And one of the main objectives of this working group is to support this energy transition. This transformation, the working group 4 must also support this digital transformation introduced in every aspect of economy and customers' daily life. Our working group is much focused on the customers, is centered on customers. Bring innovations related to digitalization of energy sector. Basically, here we try to keep track of the research and innovation projects and try to understand if they are in a good direction, and if not, try to provide new guidelines. Of course, we try to contribute with the expertise that we have inside our working group to get better knowledge of ongoing research and innovation projects. Okay. So basically, can we say that by 2025, can we predict that 90% of commercial and industrial and 70% of residential customers will run energy smarter? Okay, here we have a representation of the energy chain. So we have the generation, transmission, the networks, transmission, distribution, retailers, and the customers. Basically, if this transformation has to take into account the goals for that we want to achieve by 2025, that are reductions in CO2 emissions, increased electrical vehicle integration, reduction in operation costs, reduction in peak of average load, reduction in consumption. To do this, the digitalization is very, very important, and it will turn, we can come up with smart transportation, smart buildings, smart manufacture, smart cities, and at the end, smarter customers. Okay, so digitalization here has a crucial role. Basically, it has to optimize all this chain. It must support also the development of new services and help lowering the cost of the energy, trying to get it closest, cleanest, and most cost-effective for the customers. The digitalization must also support customers as regards the participation of the customers on the demand response, the visibility for the customers to the other entities in the chain, and so on. Our project is based on these documents. This report is called the Digital Energy System 4.0 by ETP Smart Grids. It basically has the projects and the digital use cases based on the digitalization of the energy sector. Is the basis for our work. The main conclusions that we get from this document is that digitalization actually is happening. The cost benefits is not always positive, but it's becoming more and more positive with increasing of distributed energy resources, and with new business cases, new business models for the customers, for demand response, and so on. Actors need to adjust their internal operations, their business strategy, so they have to adopt new technologies. They have to interact more using dedicated platforms for data exchange. Regulation plays also here an important role because it has to provide incentives to develop this digitalization, and also funding research agencies, are necessary to turn this possible. In the working group 4, we want to go further on the instructions, on the advices for having a better digital energy system. So basically, these were the 10 recommendations, top 10 recommendations for digital roadmap in Europe. Basically, it's predicted to spend around 50 billion euros for digital transformation in Europe. In our working group, we try to address some of these recommendations. In our point of view, the most important ones are open electronic marketplaces to boost digital energy, to leverage the digital technologies so we can have open and flexible markets, digital home technologies, so we can shift consumption, residential consumption during the peak demands. We have to come up with disruptive digital technologies so we can apply in the digital use cases. We have also to support and set up a virtual innovation hub so that new energy services can be created. Based on these recommendations, we have created inside Working Group 4 3 task forces. So basically, in the first one, we have the enablers. So we turn this possible. That are the technologies, the architectures of the systems, and the standards, data science, modeling. Then we have the services. So basically, the use cases, the new market, new business models. And we have to turn this digitalization robust. So we also address cybersecurity recommendations. We have, during the work that we have performed in the Working Group 4, we have contributed to ETIP-SNET implementation plan 2017-19. We are also working in position papers regarding all these aspects related with digitalization, and to come up with a roadmap for future R&D projects. Basically, we have as a basis of our work, we have in mind that we have to come up with the full digitalization in both transmission and distribution networks. So basically, we want to develop tools for monitoring, automation, control, cybersecurity, use big data, Internet of Things, tools to network management, develop smart management strategies, so we can manage to work with the network closer to physical limits. We also want to coordinate the participation in standardization activities for communication, data exchanges between stakeholders, large-scale data management, so develop scalable solutions for the large-scale data management in our energy sector. Ensure, of course, physical and cybersecurity of digital substations and the digital and use cases related also with these digital substations. Regarding cybersecurity, we try to define what are the issues related with cybersecurity, namely the confidentiality, integrity, vulnerability, availability of information flow, considering the different layers of the state grid architecture model, identify which are the standards that exist, perform a gap analysis to these standards, and provide a potential improvement for them, explore the research and innovation projects related to cybersecurity in what concerns smart grids. We are starting having more and more consumer data, so we must leverage the knowledge related to that. So we must have efficient, or come up with efficient data mining algorithms for the various applications that we can have in the energy sector, namely forecasting of generation tool, consumer behavior, models for network components, for failure, for aging. Data miner algorithms also to create new business opportunities for market players. Address the data privacy. The data privacy is also very important, and at the same time ensuring transparent, non-discriminatory access to all market players, and develop standard systems, so as regards with smart meters, so we can have interfaces connected to smart appliances in our homes. And the last but not least, the consumer involvement in the development and operation of the energy system. So basically, try to improve the public awareness of long-term energy challenges that need to be built, and also to protect energy infrastructure, so we can increase the social benefits of the energy use. Also involve the consumer on the assessment of new environmental challenges, environmental integration of the energy sector, and exploit also new channels for public consultation processes. So this is the scope of our activities in the Working Group 4. Thank you very much, and I hope we have a good, fruitful part 4 discussion on this ETIP-SNET workshop. Thank you.
Well, time for one question. Who has the question for Bruno? I have one, if there's none on the floor. You know, a stupid question, sorry. Is it digitalization or digitization?
I think we can apply more or less the same word, because
it's the same thing.
Yes, I think as long as I'm concerned, it's the same thing. Okay. But the name is digitization, but I've also heard and read digitalization. So.
Okay. Sorry for this question, but I'm confused by these two terms. You know, one might came from the French actually, and the other one maybe. Who knows? So okay. Thank you very much. Let's talk in the round table after the lunch.
Thank you very much.
Let's now come to the first project presentation in this group 4. This is by David Fallon. Welcome. From Ireland, he will talk about the Power Off and the Save project. Please.
Hello, everyone. Is my mic on? Can you hear me?
Yeah.
So My name is David Phelan. I'm an Innovation and Smart Technology Engineer with Electric Ireland. We are a supply company in Ireland, and we are working on a collaboration project in terms of residential demand response with EirGrid, who are the TSO, and you've heard a presentation earlier by my colleague Ian Connaughton. So essentially this project is about recruiting about 1,500 customers and asking them to reduce the demand in the home without affecting the comfort of the home. So EirGrid would send a signal to Electric Ireland, we send a signal then to the customer, maybe a text message, we give them a load of technology which I'll describe in some slides, and they reduce their consumption in the home, to turn off whatever appliances that's possible. So this project started last year in early 2016. It's an 18-month project, and we hope to finish up in March 2018. We're halfway through the project. We're gathering a lot of learnings that I'll describe later. The whole idea is about getting, I suppose, flexibility of demand. We talked about flexibility of generation earlier, and what we want to do is carry through and test the three things that you mentioned: provenability, measurability, and scalability. So there's a number of benefits on this project, and what we're looking to test, and one of the first things is looking at it from a policy perspective. There's a lot of European and national energy efficiency policy targets that we must reach, and this is one of the things that we'll look at in the project. In terms of power system perspective, it's the first of its kind where, especially in Ireland, where TSO has collaborated with a supplier and they're looking at residential demand response. There's also a lot of potential for accommodation of intermittent renewables, enhanced generation adequacy, and also then, potential for avoided deferred network investment. Some of the benefits from a consumer perspective, could have reduced bills, greater control and awareness of what they're using in the home. And some of the key learnings then, is there actually a residential demand response at the end of this project? Is there a market there? And what's the size of the market? In terms of residential energy end use, or residential electricity end use, it's about 30% comes from the residential market in Ireland. So in terms of residential consumer behavioral insights, customers have the ability to respond to a notification from Electric Ireland. They can switch off appliances and reduce their electricity. We're going to test their attitude towards this project. Are they willing to take part? There's a lot of, at the moment, maybe manual intervention. We're giving them technology that there's automatic intervention that won't affect their comfort and they don't have to think about it. Then we want to test also the technologies that we are proposing, their usefulness, what sort of payment mechanism should we use. At the moment, there's 10 events, we're paying them €10 maximum per event per customer. So, and what's the customer journey then, the installation of the technology, does it take long? Is there many visits from a contractor and so forth? Just to give you some information on Electric Ireland and who we are, we have about 1.1 million customers, residential customers in Ireland. We are a leading electricity supplier, and we also supply gas as well. We have a proven track record, and we're a trusted brand, and this is very, very important for engaging with customers and recruitment especially as well. And we've proven that we have strong capabilities as well. In terms of partnerships, we partner with a number of different companies. We started off a few years ago in terms of smart heating controls. We partnered with Honeywell, with Nest, with Climote, which is an Irish company. And further down the line, we're looking at we've partnerships now for smart hot water companies. In terms of Climote, again, they're developing a smart hot water controller, and I'll talk about that in another slide later. And then we've partnered with Accenture and Glendimplex in Ireland. So this really is the overview of the main slide of the project. And as I said at the start, EirGrid send a signal to Electric Ireland. So we focus on the left here, at the very, very far left, and we look at verticals. So EirGrid send a signal to Electric Ireland. Electric Ireland then send a text message or a push notification through an app or an automatic signal to a technology, to a range of technologies. And then what we can do then is we can switch off appliances in the home, or the customer does that and responds to it. And it could be manual intervention or automatic intervention. All this data is then collected and aggregated up, and the aim is then at the end of the project to have potentially 5 megawatts. And what we do as well is we have a partner with a professional customer research agency called Ipsos, and we carry out surveys with the customer throughout the project and focus groups. Just to give you some insight into one of our key technologies that we have, and it's called a smarter home system. Essentially, it's a gateway in the home, which is a white box like a Wi-Fi router, and that is the brains inside, I suppose, the home. What we put in place then is some metering capability, so a CT clamp and whatnot, and then we can control then, or the customer then can control and monitor through smart plugs as well in the home using an app. And all this data then is collected and produced on an app, and they can see in real time how much electricity they're using, control different appliances in the home, and they're finding it very, very useful. At the moment, we have about 500 customers already trialing this technology. So just to give you an example on some of the screenshots, and this is something I took from my own home that I have the technology in, and it shows when the hot water system is on. In Ireland, we call it the immersion. So when I turned it on, it was about 2,000 watts, and next thing you can see in real time the electricity use. Also on the app, you can see your bill, your estimated bill. So there's a lot of smarts built in, and then disaggregated data then on which appliance is using what and how much electricity it is as well. And all this then is developed and is available in the app. And customers typically like to use an app on the phone as opposed to maybe on a website just to see this information. Another key technology is retrofitted into the hot water system in the home. And 80% of homes in Ireland have this type of hot water system. And essentially, it's a simplified app. It shows them how much hot water they have. It's like the battery on your phone. And then they can turn it on or off, boost it whenever they want, and schedule it for the week. They don't have to think about their hot water requirements. They also have a hub in the home so they can physically go up and do whatever controls they want as well. So we have capability at the moment to switch this off whenever we want for as long as we want. And the idea is not to affect the comfort of the home. So in terms of system services that we heard earlier on and qualification trials and the DS3 program, this is what we're looking to do and test it out and make sure that it's proven, and how quickly can we react to spikes and drips in the system. So just to give you an insight into I suppose the amount of work that's required in terms of customer recruitment, we have a large base of customers, and they're engaged in so many different ways. We get a lot of emails that they want to take part in smart trials, and they're willing to take the technology for free and test it out and provide information back to us. So that's where we started off. We send a large amount of emails out to a customer base, and just for example, from all the different customer bases we've roughly 12,000 we could have sent out emails. Only about 5% then actually carry out a survey, which is probably a 20 question survey, and then we carry out maybe a physical survey in the home. Will the smart energy system or smart hot water system fit into the home, and is it suitable? Customer agrees to terms and conditions, and then an installation is carried out. So at the moment, we've carried out about 6 events, and we've looked at the reaction times, and we've got 5-minute data. We do have capability to get 5-second data, but just putting this slide together shows within the first 5 minutes, almost 30% of the homes, or 30% of the cohort that we're testing reacts straight within that first 5 minutes. And then at the very end, 30 to 45% do not react at all. So maybe, they may be working, they're not in the home, depends on what type of technology they have, and it's an interesting insight. So I'm going to take a risk and play a video for this. This is the project. So in terms of the key positive learnings, we're seeing about 50% of the participants are reducing their consumption during each event. And this will increase as the more automated technology that we provide. There's a positive reaction from customers to taking part in this type of project. They see that they're facilitating renewables and giving more flexibility towards the grid. And the technologies that we're providing gives them better control and monitoring capability for whatever they have in the home. Some of the key issues, we ask customers to switch off appliances within the home, and sometimes they might switch off too much. And for example, if they switch off the Wi-Fi, then the data is lost. So that's an interesting one. So we get to communicate to the customers, and we just say, switch off as many things as possible, but leave the Wi-Fi on. Suitability of the customer homes and various technologies, as you saw before, there's a slide. Some homes just are not suitable for this, and a broadband is maybe a key requirement of certain technology. We do have other technologies that use SIM card and GSM. And then there's a requirement now on the project to scale up significantly and to integrate a frequency meter, so then we can partake in DS3 trials and qualification trials, etc. In terms of customer participation, there's a lot of education in this type of project. The customer has to be educated on the technology, what's involved, how does it work. In terms of the Power Off and Save events, what's involved, it's 30 minutes. If you're not home, don't worry about it, maybe take part in the next one. And then the payment mechanism. So we split it out into two types of payment mechanisms. If you just reduce, you might get the full payment. The second group then is if you reduce by a certain percentage, you get a payment, up to €10 per event. And then the reaction times of customers and the technologies. As I said, we're implementing more automated technologies. We're looking at faster reaction times. We have the data for 5 seconds, and it's very interesting. So for the remaining 6 months of the project, as I said, we're at midpoint stage now. A lot of learning still going on. Introducing more technology, and just we're looking at one of the extra things we're looking at is maybe solar PV generation in the homes. We might look at, we're investigating the possibility of maybe switching off solar PV. So not just switching off demand, but switching off generation. It's a key thing, whether it's technically possible for the homeowner to do it, but also would the homeowner be willing to do it. And then finally, then the interpretation of technologies to meet the system services is a key step as well. So thank you very much.
Also, thank you for staying so well in time. We have almost caught up. Questions to David? Yes, please. Two.
Yes, very interesting. Do you have any idea or some assessment what happens in the following half an hour? Because you said in the previous half an hour there is a consumption, then there is a switch off.
Yeah.
Evidently there is a saving.
Yeah.
But does this, in terms of power, it's definitely a service. But in terms of energy, during the day or longer periods, do you think this energy is then consumed later on, and then the bills actually is not very much impacted, or there is a net positive effect? Are you going to calculate this, or?
Oh yes, so I probably should have went into a bit more detail on that. So it depends on the time of the day we carry out the event. So we've carried out 6 so far, and for example, we've carried out some in the morning, which would have a low participation rate. You're talking maybe about 50 to 100 watts per home. And then if it's in the evening, there's a lot going on. There's maybe people are cooking and whatnot. And we carried out an event at 6:30 during the day or during the week. And you're looking at maybe 200 watts per home. We also tested, interestingly, at the weekend, maybe a Saturday evening and a Sunday evening. And what we have found from our results so far is that a lot of people are busy at the weekends and they switch off and physically, sort of in their mind, switch off and don't care about a text message or may not see it on time. And the reductions in the home has been a lot lower. You're looking at 50 to 100 watts per home. So hopefully that answers the question.
Thank you. There's a second question, please.
Good morning. I am Ignacio Benitez from the Energy Technology Institute in Valencia, Spain. And I am very much interested because if I understood correctly, you just said that you are able to control the appliances from the mobile phone. And I would like to know how you can do that.
Yes. So first of all, before the project or a customer is signed up to the project, we give them terms and conditions and say to them, is it okay for Electric Ireland to switch off appliances in the home? And the typical appliance is the hot water heater. So for example, it could be, it's integrated on a platform, so we can log into a website and we can switch off all appliances that are, say, that are hot water heaters. And so a communication by GSM, a SIM card, is sent to the hub in the home and is physically switches off a switch then in the distribution board.
Okay, but I saw in your slide, for instance, a washing machine.
Yes.
So you are not able to modify the operation cycle at all. You're just switching off the line.
Yes. So for example, a washing machine would be plugged into a smart plug, and if the customer has opted in under settings on the smarter home system for automatic switch off, we can turn off that smart plug. It's a communication. I forget it now. It's through broadband in the home through Z-Wave technology communication.
What technology?
Z-Wave.
Z-Wave.
Z-Wave communication.
Okay, thank you.
Thank you very much. I think let's keep the discussion for the roundtable. The other questions. Thank you very much, David. Now let's go to the last one before our lunch break. Last presentation. This is done by Pedro Ferreira from EDP. He will talk about the Predis project in this nice country.
Thank you.
Thank you.
So, good morning, everyone. First of all, thank you very much for the invitation to talk about the project. I wonder if it's worse to be the last of the morning or the first of the evening. We'll see. We'll see. So I'm here to talk about this project, which is Predis. But before, I think you already, I will just give you rough numbers, but you already know EDP Distribuição. And the things that I want to reinforce here in this slide is that they more or less have 470 substations, 70,000 distribution transformers, and roughly 6 million clients and users. And I'm Pedro. I work in EDP Inovação, which is a small company within the EDP group. And our goal is to promote innovation for the business units. We have, or try to have an open innovation approach. We are divided from the technical side in 5 strategic innovation areas. I belong to the smarter grids one. And we also trying to develop a lot of ways to promote innovation since the inception, since the idea, up to really established companies like with our venture capital fund. So, in our opinion, we are living, I think, in the most profound, in a time where we will have the most profound change in the electrical sector since its inception. It was already mentioned that we have exponential growth of distribution generation. Storage is soon be a reality. Electric vehicles also finally are ramping up the sales of electrical vehicles. And utilities need to deal with all this information. And there are tools to do that, big data, IoT, machine learning, all of that. And it's our opinion that utilities need to really know how to leverage on these technologies and take the most gain of all of these technologies to cope with this scenario. And if I need to choose a slide to describe the project, it would be this one. It was done in a board that we had in our previous office. I miss those boards because here we don't have them. And I think it says it all. So we have a lot of data that is coming from several sources. And we need to collect that data in a place where we can have teams that look at the data and try to see what can we get from that. And from that phase on, we can put those models in production and feed our board's members with useful information, which is the new building that was still being built at the time. So how did it all start? Around 2013, we watched some presentations from IBM and EDF, the research center, where they were doing experiments with big data. We did also our experiments in the cloud at the time, and we tried to reduce, to see if the big data was what it was claimed. So if you could increase decrease the processing time, if it was resilient, if it was able to cope with failure of the node clusters. We did some tests, and we had very good results and some very good insights. Afterwards, we envisaged this problem, this project, Prediz, and at the time, EDP Distribuição was installing meters in all the distribution transformers, 70,000, and we thought, okay, let's have the goal to do real time, not as a SCADA system real time, but not also in a daily batch framework. Let's try to do a real time load and generation forecast and do it for each grid node. And for that, we needed to assemble data from a lot of systems from EDP, external sources of data, and we started up. It was clear for us that we needed to develop knowledge in these 4 areas. Analytics, different ways of doing analytics, to know how to assemble and manage big data infrastructure, also to be able to integrate data in this system, and also one thing that is really important for me, at least, is to develop and retain know-how in the house. Because if we are going to the digital utility paradigm, to an energy web paradigm, I think the utilities need to really know to handle all this data. They need to transform. So the first challenge was to ingest the data from the systems, and we did it the hard way. It would be easy to go, make an extraction, and put the data on the system, do it daily, but we tried to develop a way so that the data, as soon as it's generated in the source systems, it's delivered in the big data cluster and is available for exploration. So we started to look at these tools from the Hadoop ecosystem. We try to, as much as we can, to use open source tools. Hadoop ecosystem, also R, a programming language. We started to use Kafka and Spark, that at the time they were a novelty, and now they are more standardized. And we managed to implement a process where the data is available more or less with a slight delay, but more or less as soon as it is generated in the source systems. Sorry. And for the analytics phase, we more or less have the process divided in these 3 stages. The first one is data discovery. As soon as we have the data, we start to look at it and start to try to understand what is going on with the data that we are trying to look at. Once again, we use the R tool, which is free, open source, and it could be integrated with the Hadoop ecosystem. This is an example. We started to try to forecast national load to see if we could have a good model, and this is an example of that. After we know and understand a little bit what is going on with the data, we start to model it, and that's the second phase. This is an example of the variables that we used to improve the model. It was, I think, some of them are pretty similar, which is I think normal to the ones that EDF used previously, and with that we were able to achieve good enough results. We have the notion that this isn't the perfect model for all the grid elements, but it gives us a good average all-round forecast for all of them, and of course we'll dig in a little bit further. But for the time, we stop more or less like this. And the third part is picking up these models and putting them in a big data cluster and working in a big data cluster. Because there are some challenges here also to optimize the processing times. So these are some data. They can be better, but they are not bad at the time. We more or less using, also our cluster is I would say, not an amateur cluster, but it's not a real big enterprise cluster. But we are able for now to do daily forecast for 40,000 points in 3 hours, using more or less half of the processing power. And it was before an upgrade that we've made in August. So I don't know how will be the times, but I expect that they decrease linearly, as is a characteristic of big data. And we also have a rough measurement of the forecast errors. And for me, one of the most rewarding things about this project is to be able to integrate with other business units and really bring them to learn with us all of these. Because in the end, all that we develop in EDP Innovation, it will be for them. And it's I think, my goal, personal and of all of the people that work in Innovation, to pass this knowledge to the business units. So we more or less have this model. It looks really good, but it's just a few meetings that we have with them. And for the time, only EDP Innovation is really working on that make part where do we develop the models. But we are always insisting with our colleagues to come and work with us and really help us develop the models. So first thing we do is we talk with the business, to the EDP Distribuição in this case, ask them if what we are planning to do is what they want. If not, they give us some feedback. After that, we do develop the models and check and come back with them to check if the models are in a good way, the results are good for what they need. And this has been a really fruitful relation that we have been, because I think it enriches a lot both parts. Also, we have been promoting actively, as much as we can, some work with universities. Our goal here is to have the universities to work a little bit ahead of what we can do. Some challenges that we know that are up front of us, and we try to give them, pass them those challenges and support them whenever we can, to afterwards to collect those results and incorporate them in what we are trying to do. And last but not least, I think it's the last of this more or less ecosystem, we try to deliver the information that we generate and adequate it to different type of usage. So the first, we developed an API so that the other systems can go there and pick the information and use for their operations. Also, we are developing, we have access and give them the code so that the data scientists from the business units can work on that and improve it. And for end users that just want to see the results, we developed a Google Maps layer where we, on top of and this was made on top of a project from EDP Distribuição, and we click on the asset and we have the load diagram and the forecast for that asset. So, main results. So we are now doing daily forecast of 40,000 elements. In 2 weeks' time, we'll expand this to roughly 100,000. So one good take from here is that scale really isn't a problem. I think we should aim to scale. It's not hard to manage and have the processing for a lot of grid elements. We also learned how to develop a big data infrastructure and supported a lot the IT department in choosing their own and the official one, I should call it this way. And again, the internal knowledge that we developed and gathered, and which is very important. For me, for us, the next steps on these projects are to increase the number of forecast points, also to support a pilot with dynamic tariffs that will start in the beginning of the next year. We would like to incorporate grid dynamics in these forecast models. So for that, we need to try to model the grid with a graph. It's a challenge that we are trying to solve, and really put this so that the forecast can be done in a 15 minutes framework for all of these points. And the final aim is to reach the 6 million points that EDP has. With big data, it's not a problem. It's horizontal scale, so we need to reinforce infrastructure, but and it's something that can be done. And thank you very much for your time.
Thank you, Pedro. Please just stay for a few minutes. Very impressive try here to innovate. What are the questions from the audience to Pedro?
Lunchtime, right?
Lunchtime, yes. But I just, what I observed is here, we always ask, what can we do new, And an engineer would say, what do you measure and what do you do with it? He would ask about our algorithms which you use. But it seems like the main value is internal at your institution, because it allows you to go to the colleagues and talk about internal developments and knowledge. So I was impressed by the statement that you say it helps to develop internal relationships and knowledge, actually. Is this a topic, do you put a measure on knowledge gained, in such a project, or how do you handle
Unfortunately, not yet, because I think it would be nice, but we don't have that as a measure. I think it's some mind frame that we have in innovation, and also our colleagues respond, I think, very positively to that and help us a lot. They also have that mind frame. I think it's a culture. I think we need to put it as a cultural way where people really work together, and that, luckily, I think we have been able to do that, and it's really gratifying.
Very, very interesting. Yes. Question, please.
I have one question. Rui Pestano, the Portuguese TSO. As I can see, my question is this. How do you going to deal with the PV behind the meter? Because it is going to be net load, negative load.
It's
how
it
behave the load forecast?
I don't have an answer for that. It's an interesting question, but I think we started we developed a few PV forecast algorithms. In EDP Distribuição, we have 4 stations spread in the country with PV panels, so with good data sampling. So we developed some models to forecast PV with that sample, and actually in this last summer we had an internship, and his goal was to pick up on those models and try to apply them with the type of data that the DSO can see, which is 15 minutes readings. And the results, of course, are worse, sorry. But nevertheless, we have, I think it was more or less 20% average error on the forecast, which is not good, but it could be worse. But the thing is, this type of projects may be very important to help people to realize and justify the need to get more data. And with that, who knows if the DSO can talk to the regulator and say, okay, if we want to massive implement PV, we need to be sure that we collect this type of data or something like that, so that we can keep on managing the grid. So for me, I think this one gain, not directly with the forecast, but that can help to understand what can and what cannot we do with information that we have at our disposal right now. Sorry, it's not, but I don't have a solution.
I think he's talking about the learning process within the company. How do you handle and structure that? And the answer is we don't know all the answers, but we are doing something to be ready, for the new challenges. I think that's what we hear. Further questions from the audience? I have one more. Okay. Open source. You have experience with using open source, I think.
Yes.
Is it true that Kafka and Spark are open source environments?
Yes.
Who in the audience knows these open source environments? Kafka and Spark. I just wonder,
Two people in the corner know, because they are the responsible for this, Margarida and Marco. And but these are Hadoop started as the first big data, and since then first open source tool, and since then have been developed a lot of tools that gravitate around Hadoop. These two are two more of them. So we have Impala, other type of tools.
Okay, thank you very much.
No further.
If there are no more questions, then I would propose we can come back later in the roundtable discussion, but now let's go for the lunch break. Yeah. If you all agree. Thank you very much for your very good presentation. And please, let's be back at 2 o'clock. That's in 1 hour and 5 minutes.